All right, so looking at this worksheet, the second worksheet, it's page 380 in the book, and a couple years ago I just turned it into a worksheet to make it easier. Let's look at a few of these. So number 13, it kind of looks like inverse sine because there's a square root in the bottom. And there's an a squared minus u squared sort of set up. So a is 5, that's easy. U, we think would be tangent, especially when we consider what du would be. Secant squared. So yeah, that all matches up just right. So the top is du. And the bottom, I'm not going to rewrite this because the bottom is already a squared minus u squared. So this is going to be inverse sine of u over a. So tangent x over 5 plus c. And I guess that's it because the du already took care of it. Inverse sine does not have the 1 over a out front, only inverse tangent does. And so, if you pick the right u, then some of these go really quick. If you pick the wrong u, then you're kind of spinning your wheels and you're stuck. All right, let's look at 19. I'm a little worried about the length of 19, so I'm going to work it on a separate page. I don't know if I can get it all in right there. So again, it kind of looks like inverse sine, but the x up there makes me think, no, not so much. But maybe this is a split it up problem. X over part of it and 5 over part of it, or whatever the numbers need to be to make things work. So let's start out thinking this is inverse sine and see what we can do from here. So a would be 3. U would be x minus 3. du would be dx. Okay, so that would all be fine. So let's start to split this thing up. X over square root of 9 minus x minus 3 squared plus antiderivative of 5 over square root of 9 minus x minus 3 squared. So pretty sure we got this second one figured out as an inverse sine problem. There's a 5 there, but that's not a problem. We can take that out front. So now I'm worried about this first one. Because if I let u be all of this, 9 minus x minus 3 squared. Let's see what happens here. Because we're going to need du in the top. X squared minus 6x plus 9. So u would be negative x squared plus 6x. I don't like where this is heading because du is negative 2x plus 6. And I don't have negative 2x plus 6 up there. I've got x, so I could sort of fix the x part with the negative 2 and the negative 1/2. But I can't just go putting a plus 6 up there. Although, if I do a plus here and a minus over here, that would be the same thing. So I really want this to be negative 2 times x plus 3. So I'm going to use, let's see, I want this to be plus 3. right? But that's illegal to just stick a +3 in there. That's not okay. But let's see what I really did, and we could account for it in this second part, because these have the same denominators. So when you multiply, you got to multiply top and bottom to keep things the same. When you're adding or subtracting, you can add or subtract to both terms to keep them the same. So I wrote +3 to make it fit. Now I need to figure out exactly what I added in there. And it looks like, goodness, that's a lot of math to keep up with here. -1/2 times -2 times 3. That's what I really added up there. So that would be equal to 3. Oh, so it turns out I did add 3. But I had to go through some hoops to figure out that even though I wrote +3, I actually added +3, so that worked out. So that means if I added 3 to this term, I can subtract 3 from this term, and I haven't changed the overall situation. So this one is really sneaky because you had to multiply top and bottom, but we're used to that. That one wasn't bad. But in order to make the top be du, I had to add something, which normally we're not really allowed to do, except that I could subtract it from the second piece, and I didn't really make things any more difficult. All right, so now I'm ready to integrate these two. So all of this is du for my first one. So -1/2 antiderivative of u to the -1/2 du. Well, let's finish this one out, and then we'll go back and catch this other one. So -1/2, increase the power by 1, divide by the new power, times 2, and then plus c, but I'll add plus c at the very end. So negative u was 9 minus x minus 3 squared to the 1/2. Now back to the other one. 5 minus 3, I'm just going to move out front. So I've got the integral of 1 over square root of, let's see, a is 3, u is x minus 3. Some folks would skip this step because you already kind of got it written up there, and you might be okay to skip it. So inverse sine of u over a, x minus 3 over 3, plus c, but I already said I'm just going to wait till the very end to do the plus c. So down here at the bottom, 2 inverse sine x minus 3 over 3 plus c. What a crazy problem. The trick was forcing the du to work. We've done that before, but we've not done, the new stuff is here in green, we've not done a +3 minus 3, because usually that's not really an option. But since they have the same denominator, and we've already split it up, it works out for us for this one. So 19, that's a tricky one. Let's do 33, speaking of potentially tricky ones. Evaluate the integral by completing the square. We haven't done that in a long time. Okay, let's look at our goal in mind here. What do you think we're headed for? Like which antiderivative are we headed for in number 33? Do you guys know? I mean, there's no square roots. So it's probably inverse tangent. And so I'm looking for a squared plus u squared for that to be inverse tangent. I don't really have that yet, but maybe that's where we can work toward. All right, it said complete the square. So complete the square. That's where we half the middle term, square it, and add it to both sides. Although they're not really both sides, so I have to figure that out. B over 2 is negative 1. So if I square that, I get positive 1. So I can add it right there. That makes that a perfect square here. But I can't just go adding 1. That's not allowed. So I can sort of counter that by subtracting 1 later in the denominator. So rather than add 1 to both sides, because there's not both sides, I add 1 and subtract 1. And so now I've got a perfect square. It's x minus 1 squared plus 1. And that does look like the inverse tangent. It's a little bit maybe out of order. We usually have the a stuff first, like the constant first and the variable stuff second, but it's added, so order doesn't matter. But it does get a little confusing your first time through these, so u squared, b squared. So u is x minus 1 and a is 1. And of course, those are convenient because du is dx. And a equals 1 means if we forget the 1 over a, it won't change anything. So 1 over 1 inverse tangent of x minus 1 over 1 from 0 to 2. So that would be inverse tangent of 1 minus inverse tangent of negative 1. And that would be a safe stop. Because that's calculator ready. Like you can type that in a calculator and get an answer. Inverse tangent of 1 is pi. Inverse tangent of, nope, that's not right, is pi over 4. Think about that. That's what I get when I don't draw a picture for those. Inverse tangent of negative 1 is negative pi over 4. So we add those two together, we get 2 pi over 4, or pi over 2. So there's our multiple choice answer. All right, let's look at 39, and we'll call it a day. 39 is another one where that's probably not going to fit on the page. So you can do it on the back if you want. Integral from 2 to 3, 2x minus 3 over square root 4x minus x squared. Goodness. There's like 3 different things that immediately pop to mind here. It looks like inverse sine on the bottom because of the square root and with something squared. So I'm thinking inverse sine. The 2x though makes me think not inverse sine, but like substitution. So that makes me think I'm probably going to have to split these up. And I'm going to have to complete the square in the bottom, which probably means I'm going to have to fix a whole bunch of stuff. So like all this is going through my mind. Inverse sine, but split them up. Be careful with the du dx stuff. Probably have to complete the square. And when I say careful with the du dx stuff, I mean for both the inverse sine and for the power rule problem. Because I think one of them is inverse sine and one of them's u to the negative 1/2 with the du in top. So I've got all that stuff kind of going on. Let's see if we can figure this out. Inverse sine looks like square root of a squared minus u squared. So maybe we aim first for that, see what happens, and then we'll figure out exactly how we need to split this thing up. So I've got some algebra ahead of me here. So I'm thinking inverse sine, so I'm going to rearrange things to make them look like this. So minus x squared minus 4x I factor out a negative, kind of rearrange things, because I want this to be u squared, and whatever ends up there, I want to be a squared. And then I'll be at least on the road toward inverse sine. So let's complete the square. I can color code this thing. So half of b is negative 2. Square that and add it to both sides. Well, it's not both sides, but add it. And then figure out how to account for the fact that we added it. So plus 4 to make a complete square. Except we wrote plus 4, but what do we really do in the denominator? Like I wrote plus 4 to complete the square. But what really happened when I wrote plus 4? Because of that minus sign. I subtracted 4. So what else do I need to do in the denominator to account for that? I need to add 4. So that feels a little weird that we added 4 twice, but we didn't add 4 twice because one of them had a minus sign on it. So 2x minus 3 over square root of 4 minus x minus 2 squared. Okay, so I've got the denominator that looks like inverse sine is supposed to look. So I feel pretty good about that one. Numerator is still messed up. So I think before I split them up, I think I'm going to take care of the inverse of the u to the, if u is the bottom, so this is the du dx concern here. If u is 4 minus x minus 2 squared, which maybe I should have done this earlier, because all of that's going to reduce to 4x minus x squared. So maybe I should have done this earlier, but I was off on the inverse sine track there. So du is, I'm going to rearrange the order here, negative 2x plus 4. So I need the top to be negative 2x plus 4. Or maybe I should rewrite that as negative 2 times x minus 2. Running out of colors here. Right, so next let's work on the split. We'll do that in blue. So this is what I'm aiming for. I don't have that, so I'm going to split them up. Let's see. So this one is 2x. The other one is going to be minus 3. In fact, I'm just going to put the minus 3 out front. No, I'm not either. I want to keep that minus 3 in the top because I think that'll help me. All right, denominator I'm not really worried about, so I'm going to be lazy and not write it because it's the same. All right, so I want my numerator of this one to be negative 2 times x minus 2. So I can put a minus on there, and then a minus out front to account for that. And a minus 2 in there. Oh my gosh, I've got negatives all over the place now. So I wrote minus 2, but I really went negative, negative, negative. I really did a minus 4. Yeah? So I need a plus 4 over on this one. So that minus 2 and that plus 4 are kind of the same thing. And so on this first one, I've got du over u to the 1/2, u to the negative 1/2 du. And on the second one, actually that worked out great, because now I've got 1 in the top over 4 minus x minus 2 squared. All right, now I'm finally ready to integrate, because I think I've got this down to, that's inverse sine. We already said who u is, and a would have to be 2. And then this one is just a power rule. So increase the power by 1, divide by the new power. So what was u? I got to go find u back up there somewhere. I've got it written down a couple places. I don't know that that's the easiest one to write down, but that's one formulation of u. If you'd written the other formulation of u, 4x minus x squared, that'd be okay as well. Plus inverse sine of u over a. Plus c. Oh, no, not plus c, because this had limits on it way back there. I got lazy and dropped them, knowing I'd put them on at the end, and then nearly forgot them at the end. So that's the last thing about this problem. For the test, I should just give you one like 39 and just say that that's the test. Except that it would be a bear to grade. All right, so from 3 to 2. Yeah, there's no shortcut around this. So let's plug in 3. Kind of setting it up ahead of time because this is going to get complicated. So I'm going to plug in 3 minus plug in 2. And once I plug in, I'll have a safe stop. So I'll have a really ugly safe stop on this one. All right. Which formulation of this thing do I want to use? I don't guess it matters. I think I'm going to use the first one. So negative 2, 4 minus 3 minus 2 squared to the 1/2. There's the 3 that I plugged in. Plus inverse sine of, well, I guess that should show my work, 3 minus 2 over 2. Minus, now I'm going to do the same stuff with the 2. So negative 2, 4 minus 2 minus 2 squared, all to the 1/2, plus inverse sine 2 minus 2 over 2. And I guess I need parentheses on there to make sure I subtract all of that. That would be a safe stop.
That's my favorite problem we've done all year.
That is definitely the worst problem we've done all year, for sure.
It's beautiful.
I want to finish it out because now I'm curious. And I'll plug it in the calculator and check my work. That's what you're doing.
You have to be in radians.
So you would need to be in radians.
Okay.
Yep. So negative 2. So you plug that into the calculator. I'll do it here and we'll see if we get the same thing. 4 minus 1 squared is 1 to the 1/2. Inverse sine of 1/2 is pi over 6. minus negative 2 times 4 to the 1/2. Inverse sine of 0 is 0. Hey, there's one easy thing about this problem. So negative 2 square root 3 plus pi over 6. Let's see, that would be square root of 4 is 2, times 2 is 4, plus 4. There's my answer. Let's see if it's the same.
Right, I'm almost done.
You're watching at home, someone's plugging it in, and they're almost done plugging it in, which means...
Okay, I got like 8.20 in radians, but I don't put all.
Alright, so I'll type it in, negative 2 square root 3 plus pi over 6 plus 4. Uh-oh, you did not say 1.05, did you?
No, I did not. But also I could have done something wrong, so I can't really take that, 'cause it is.
Yeah, math 9. I'll type it in, and I may have done something wrong. I feel terrible since I recorded this 20-minute long problem and then miss it. Let's see, where's that fraction
I
thing?
always cut out when we were checking it.
That's right.
Now
2x,
to know.
2x minus 3 over square root 4x minus x squared dx. 2 to 3, 2x minus 3, square root 4x minus x squared dx.
Woo!
Yes, amazing. I was worried. I don't want to say I'm surprised I got it right, but there was a lot of steps in that. There was an awful lot of steps in that. And so, you know, obviously you'd hope this would be on the calculator part of the test because it would be a 2-minute problem, however long it takes to type it in. That wouldn't be a multiple choice question because that's too long to be a multiple choice question, really. Free response, I don't even know that it'd be free response just because there's so much in there.
I think you should just spare us the hassle.
So you're not going to have one on the test like that, but it's a great problem because it had inverse sine, it had u substitution, it had power rule, we had to split it up, we had to complete the square, we had to do a couple of du dx fixes, but eventually we got the right answer.
That's something I don't have to take into.
So number 39, what a problem.